Hello everyone, thanks for stopping in, and today we're going to be looking at Math 120, section 10.1, and this section is going to get us familiar with the idea of percentages a little more. So the first example is, what is a percent? A percent is a ratio that is always given in comparison to 100. It's a ratio that is always given in comparison to 100. The per part tells you it's a ratio. Remember, miles per hour is a ratio of miles to gallons, right? We've seen ratios already. And the cent part tells you it's out of 100. Think century. 100 cents make a dollar. That's where the word comes from. The centennial year. When the country celebrated its 100th or 200th anniversary in 1976, right? The bicentennial. Bi for 2, centennial for 100. Cent means 100. So, let's take a look at our first step. Is a grade of 18 on a 20-point quiz or a grade of 22 on a 25-point quiz a better grade? Which of these is a better grade? Well, we're going to take a look at this in a bit of a different way. And what we're going to do is we're going to go the old-fashioned way with our ratios at first. We're going to set up 18 out of 20 is what percent out of 100. We're going to do our ratio the old-fashioned way. So 1800 equals 20x when we cross multiply, right? Now we can divide by 20 and divide by 20 will give us x equals 90%. X equals 90% is our first answer. So we get 90% for our first answer. In our other example, we'll have 22 over 25 is equal to, let's use the letter y, because it's a different percentage, right? Equals y out of 100. What percentage is this quiz? Well, same thing we did before. We're going to cross multiply. It'll give us 2200 equals 25y. And then we're going to divide both sides by 25. And we get that y is equal to, let's see, 25, I think it'll go in 88 times. Well, let's check. Let's see, 2200 divided by 25 is indeed 88, right? So we get 88%. So, which is better, 18 out of 20-point quiz or a 22 on a 25-point quiz? And obviously 90 is bigger than 88, right? So the 18 out of 20 quiz is better. Now, always having to set up a ratio every time you want to work with a percent isn't how we want to work with them. This is a little time consuming. It's got multiple steps. There's actually a faster way to convert. And so let's first look at how to go from a fraction to a percent. There's going to be 3 steps. The first step is convert the fraction to a decimal by dividing. And leave some space over here like I did when you're taking your notes, because we're going to draw something over here. So convert the fraction to a decimal by dividing. You're going to divide out the fraction. You're going to get a decimal. Step 2, multiply by 100. The number 100 will be coming up a lot when we're talking about percents, so get used to it. And then step 3, might seem silly, but you add a percent sign. So we divide it out to get a decimal, we multiply by 100, and we add a percent sign. So for our picture I wanted to draw, if we start with a fraction, we can get to a decimal, and we do so by dividing by what the fraction gives us. So we can go from fraction to decimal by dividing, right? We already knew that. And then we can go from decimal to percent by multiplying by 100. So we can move from fraction to percentage by dividing and then multiplying by 100. Let's take a look. 67 over 100. 67 over 100. If I divide that on my calculator, 67 divided by 100, it gives me 0.67. 0.67. And if I do 0.67 and I multiply that by 100, I get 67. So in my first example, my answer is 67%. I turn it to a decimal, multiply by 100, and that gives me my answer. 11 over 20. Let's see, 11 over 20. First thing we want to do is convert it to a decimal. 11 divided by 20 is 0.55. 0.55 times 100 is 55. So 11 over 20 is the same as 55%. And that makes sense, right? 11 is a little more than half of 20. 10 is half of 20, right? That'd be 50%. So it matches our intuition. Last, 15 over 16. 15 over 16 equals, well, if I divide it out, 15 divided by 16 gives me 0.9375. Let's see, 0.9375. Well, if I take 0.9375 and multiply by 100, I get 93.75, right? Multiplying by 100. So for my answer, 15 over 16 is the same as 93.75%. Now, a lot of times, we don't write these in between steps down. If I'm converting 15 over 16, I probably just punch in my calculator, 15 divided by 16 equals, to give me the decimal, and then I times it by 100, and that gives me my percent. A lot of times I don't write the work. I just go from fraction straight to percent. I don't write these in between steps. So if this is all you needed to do, you use the calculator and get the answer, that's perfectly fine. You don't need to write the algebra steps because we know we're going from fraction to percent. We are just converting, right? Now, going from a decimal to a percent is a lot easier. If you already have a decimal number, the first step is multiply by 100. If you already have a decimal number, you're already in decimal world, getting to a percent, you just multiply by 100. And then step 2, we would add a percent sign. So decimals becoming percents is actually a lot easier. 0.14% would be 14%. I was getting ahead of myself with the word percent. 0.14 times 100 gives me 14, right? 0.14 times 100 gives me 14. 0.893, that's going to be 89.3%, right? We just need to be able to multiply by 100, which is really hopping right twice with the decimal. 0.7625, well, 0.7625 will be 76.25%. We'll get 76.25%. So going from decimals to percents is, multiplying by 100. Not too tricky, right? Percentages are always in terms of 100. Now, lastly, how do we go from a percent to a decimal? How do we go from a percent to a decimal? Well, to go from a percent to a decimal, the first step is divide by 100 and remove the percent sign. And that's it. That's the only step. You just got to take the percent sign off and divide by 100. So let's see. 35 over 100. Wait, damn, I just turned it into a fraction, didn't I? Turning percents into fractions is really easy. You just got to put them over 100, right? That's the whole definition of percents. Well, when I divide 35 by 100, I get 0.35. Let's see, 69.8%. Let's see, I'll drop that percent sign out of there, and I need to divide it by 100. Let's see, that's going to give me 0.698. So 0.698 is the same as 69.8%. Now this one's a little tricky. 0.5%. Be careful. 0.5% is equal to 1/2 is the same as 0.5%, right? 1/2. The fraction 1/2 is the number 0.5, right? This is 0.5%. So when I convert it, I'm going to do 0.5 over 100, which gives me 0.005. Notice this is a really small number. 0.5% is a very small number, right? Think about it. 0.5% is less than 1%, right? So it's a very small number. It makes sense I should get a small decimal. So my decimal number for 0.5% is 0.005. Don't let the fraction trip you up. This isn't 50%, because 50% would be, 50%. That's the only way to write 50% as a percentage. 0.5% is 0.5%. Notice, quite a bit different, right? A lot of a different value. So that's how we can convert back and forth between these different numbers. Percentages, decimals, and fractions are just different ways of thinking of the same idea. They obviously have their advantages and their disadvantages. Percentages help us understand the values. It's easy to think of things out of 100. It's a nice even number. It's a nice number to work with. Percentages help us understand these ratios. Decimals, these decimal numbers we're working with, will help us when we're calculating. You can't type percentages into your calculator in calculations. You have to have decimal numbers. And then fractions, a lot of times, are how we set up the percentages in the first place in order to get a picture of what's going on. So let's look here. It says, according to the USDA, in 2014, the U.S. produced about 264 million pounds of cherries. So I'm going to underline that number. That seems like a good number to know. That's the total amount of cherries we produced. Let's see. Of these, 182 million pounds were produced in Michigan. So 182 million pounds in Michigan. Let's see. 36 million pounds were produced in Utah. And 26 million pounds were produced in Washington. And then 20 million were produced in other states. We'll go back to red because we only have so many colors. So I've got a whole bunch of information about cherries. Determine the percent of cherries produced in Michigan, in Utah, in Washington, and in other states. So we're going to be doing different calculations here, one for each state. One for each state, right? We're going to be doing a few different calculations because we need to work with each one. So let's look at Michigan first. Michigan, I'm pretty sure it's MI. I'm just going to write Michigan. I can't remember if it's MI or not for Michigan. I probably should know. I'm pretty sure it's MI, but not super important right now, right? So Michigan. Let's look at Michigan first. Michigan produced 182. Now, the million pounds part, it doesn't matter that it's a million because all the measurements were in millions, right? Million pounds is my unit. So I can just put this out of 264 because this will allow me, 182 out of 264 will allow me to get my decimal value. Let's see what happens. 182 divided by 264 gives me, oh goodness, we get a whole big decimal. 0.68933939. So I get 0.6893939, right? Looks like we got some repetition. I got to multiply that by 100, right? So then I multiply by 100. Gives me 68.9, and I'm going to round to 2 decimal places. The question doesn't necessarily say so, but if it did, you want to make sure you round your final answer to how many decimal places it says. So I'll round it to 2. 68.94% for Michigan. Now, I wrote a little bit of the algebra here, but we don't need to. Let's look at Utah and see if we can just follow along for Utah. Utah, let's see, it's going to be 36 out of 264. Let's see, 36 out of 264. 36 out of 264. Well, as a decimal, that would be this number. But remember, you multiply by 100 for it to become a percent, so this is equal to 13.67%. Once again, I rounded to 2 spaces. So that was Utah. Let's see, we also got Washington, so we'll do Washington. Once again, Washington, let's see, Washington produced 26 million pounds. 26 out of 264. So let's see, 26 out of 264 gives me a decimal, right? Once you have the decimal, you multiply by 100, and that'll give me the percentage. I get 9.85. 9.85%. Once again, I'm rounding to 2 decimal spaces. Now, I also need to do other states, so I'll do the others. Let's see, 20 million were in others, so I'll have 20 out of, remember the total was 264. Let's see, 20 divided by 264 gives me the decimal. So I got my decimal, right? 20 divided by 264 gives me the decimal. Times 100 will give me the percent. Gives me 7.58%. 7.58%. Now I'm going to check something. Notice we've got the different percentages here. And supposedly, based on the question, this should be all of the cherries, right? These numbers should add up to 100%. Let's check something. 68.94 plus 13.67 plus 9.85 plus 7.58. Oops, typed that one in wrong. 7.58 plus 9.85 plus 13.67 plus 68.94. Wait, I didn't get exactly 100. That's okay, because we rounded, right? It's close, though, right? When you're rounding and you add things up after the fact, you'll most likely be off by a smidge. Those are called rounding errors. You've probably heard that phrase before, a rounding error, right? These are the values we want. We rounded them, right? If we didn't want any rounding areas, we would have to leave them unrounded. But this is perfectly fine because we can round, right? Sometimes you don't need all of the decimal places. Sometimes you only need a certain amount of information. For example, I know Michigan produces almost all of the cherries based on this question, whereas the other states don't really contribute much. Utah and Washington contribute a little bit, but Michigan is the big one, right? Now, let's have a formula. We've seen some examples of percentages. Let's have another formula for an application. And this is the percent change formula. So when given, a value that changes over time, the percent increase or decrease over a period of time is defined by the following formula. So the percent change is equal to the amount in latest period. So this is the newest measurement, the latest measurement, minus the amount in previous period. You subtract the previous measurement, right? And then we're going to divide by the amount in previous period. Amount in previous. Oops, I forgot a U in that previous period. So you divide by the previous measurement, and then the last step, as almost always in percentage questions, you got to bring 100 in there somehow. We multiply by 100 and we put a percent sign on it. So the percent change is equal to the most recent measurement minus the previous measurement divided by the previous measurement times 100. This will help us set up the formula. So keep this formula handy. Maybe just set it off to the side so you can continue looking at it in your notes as we look at our next example. Let's see here. In 2014, the MLB team with the most improved winning games was the LA Angels. In 2013, the Angels won 78 games. So I have a measurement here. In 2014, the Angels won 98 games. So it's important to notice the times, because I want to determine the percent increase in the number of games won by the Angels from 2013 to 2014. So I'm looking for the percent increase, and that should be equal to, let's see, percent increase. Let's see. So I take the amount in the most recent measurement, 98, minus 98 is the most recent measurement because 2014 is more recent than 2013. So I'll put the 78 second. That's the previous measurement, right? I'm looking at the comparison from 2013 to 2014. And then I divide by the previous measurement, right? That's what this formula here told me. Latest measurement, previous measurement, right? And then I will times that by 100%. That's going to be my last step. In the top, I get 20 over 78, right? 98 minus 78 is 20 times 100%. Let's see, 20 over 78. 20 divided by 78. That gives me a decimal of 2564102. I got to multiply by 100. Is going to give me 25, and let's round to one decimal place, 25.6%. Around a quarter, right? 25% is a quarter, right? So the percent increase in the number of games won by the Angels was a 25% increase. Now, let's look at another example. On the 13th of May, 2014, the price of one share of Tesla Motors was $183.76. A few months later, on the 3rd of September, the price of one share was $287.67. Calculate the percent increase to the nearest decimal place, so we'll be rounding to one decimal place, of Tesla Motors during this period. So I'm looking for a percent increase, I'm abbreviate increase, and that should be equal to, I take the more recent measurement. The more recent measurement is the September one, 287.67, and I subtract the previous measurement, the original measurement, 183.76. And then you divide by the previous measurement, 183.76, and we have times by 100%, right? Well, let's figure out the numerator first. We got 287.67 minus 183.76. I'm going to get 103.91. 103.91 over 187.76, right? The bottom will stay the same. I still need to multiply it by 100 at the end to make it a percentage. Well, now we can divide, right? We can divide, right? Divided by 187.76 will give me the decimal, but I can multiply that decimal by 100 to get 55.3%. The question told us to round to a single decimal place, right? The nearest single decimal place. So I'll get 55.3% as my percent increase. That's a healthy increase, right? That's a pretty healthy increase over the course of only a few months. So if you invested in Tesla stock on the 13th of May and then sold it on the 3rd of September, you'd have increased your finances by 55.3%. Which is, that's pretty significant, right? Now, what about percent markup or markdown? If you've ever worked at a retail position where you're selling things, you probably know that the store does not pay the same price for those objects that they sell them for, right? They might buy them for $5 but sell them for $7 or something like that, right? That's called the markup, or a markdown. That's where the store is subtracting from the cost. Now, a positive answer is a markup, a negative answer is a markdown. That should make sense, right? Positive answers, we mark them up. Negative answers, we mark them down. So, the markup formula, I'm just going to call it the markup formula for now, the percent markup. Markdown is the same formula. It's going to be the same formula. It's just the phrasing. We say markup versus markdown grammatically. The formula is the sell price minus the dealer's cost, whoever's selling it. So you've got the selling price minus the dealer's cost over, and in the denominator, we'll have dealer's cost, and then we'll multiply that by 100%. So, we have another formula. Notice it's kind of similar to the one we already have, right? It's something minus something over something times 100%. We got something minus something over something times 100%. It's similar to the percent change form, right? A markup is just a percent change, specifically relating to finances. So remember, positive answers are marks up, negative answers are markdowns. Careful though, if I say the phrase 20% markdown, the negative sign is hidden in the word markdown. You don't put the negative sign here in English sentences. The word markdown has the negative included in it. That's why the markdown is a separate word. Markup, so 20% mark up, The markup portion hides that this is positive 20, it's plus 20%. So keep that in mind. The words themselves have impact on the grammar. So we'll keep this formula in mind when we look at the next examples. Holdren hardware stores pay $48.76 for glass fireplace screens. They regularly sell them for $79.88. On Black Friday, they sell them for $69.99. Determine the percent markup on the regular price and the percent markup on the sailor price. So this right here is the dealer's cost. That's how much it costs the store to buy it. Here's a selling price, and here's another selling price. Let's do the regular first. Regular first. The regular price is $79.88 minus the dealer's cost, $48.76, right? It's sell price minus dealer's cost, and then I divide by the dealer's cost, which is $48.76, and I multiply by 100%. Now, we've seen quite a few examples already, and hopefully we can see that I'll take $79.88 and subtract $48.76. That will be my first step. That will give me the top number. But we've seen this enough. I know I'm going to now divide this by 48.76, right? That's what I'm going to do next. Divided by 48.76. Decimal's a little hard to see in that one. Divide by 48.76 gives me the decimal, and then I multiply by 100, right? Multiply by 100 to give me 63.8%. So it's a 63.8% markup. You know, that's a pretty hefty amount of money they're making on each fireplace screen, right? How about on Black Friday? I'm going to write BF for Black Friday. Well, on Black Friday, there's $69.99. So $69.99 minus, I still have the same original cost for the dealer, divided by, once again, I'll have the same original cost for the dealer, and then we'll multiply by 100 and add a percent sign. Once again, let's see what we got. We got $69.99. We'll need to subtract 48.76. That gives us the top, $21.23. Well, now we need to divide, right? Divide 48.76. Gives me the decimal, but I need to multiply by 100 to make it a percent. That'll be 43.5%. 43.5%. So the percent markup on Black Friday is only 43%, which makes sense. It should be a lesser markup. They're making less money on Black Friday, right? How about our next example? To help get rid of his remaining 2018 calendars, the owner of Kinney Drugs reduces the price to $4. If it costs Kinney Drugs $5 per calendar, determine the percent markdown on the calendars. So, he's selling them for $4, but they cost him $5. So when I set up my equation, the sell price is $4 minus the dealer's cost, which is $5, divided by the dealer's cost times 100%, right? Sell price minus the cost for the person selling it, the dealer, divided by the cost for the dealer times 100%. 4 minus 5 is 1, right? 4 minus 5 is negative 1. Oops, 4 minus 5 is negative 1, right? Divided by 5 is negative 0.2 times 100 is negative 20%. So be careful. This would translate to the phrase a 20% mark down, right? A 20% mark down. The down implies the negative part. So it's a 20% mark down. So if the word mark down is there, the 20% is assumed to be negative, right? That's how we would write this in an English sentence. With markup, you can just say 63.8% markup, right? That works with positive numbers. Negative numbers, there's a little bit of trickiness with it. So just be aware of that when using it in sentences. The word mark down already carries the negative value for us. Let's look at the next item. Jonathan and Drew are looking to buy a house that costs $189,000. The bank wants them to place a down payment that is equal to 20% of the house's selling price. How much is the down payment? Now, this question is trying to mislead us a little bit. This is actually a regular old ratio problem. This question is regular old percentages. It doesn't have to do with markdowns or markups. The word down here is for down payment. That's just a phrase in purchasing houses. It's how much money you give ahead of time, and then you pay the rest over monthly payments, right? So let's look. The house costs $189,000. So that's the cost of the house, right? And I know that I want a 20% down payment. So what is 20% of that number? I can set up a ratio like this. And then I could cross multiply. Now, maybe you like this. This would work. Or I can see that 20% is equal to 0.20 as a decimal. 0.20. And I can do 0.20 times the original cost. If I'm comfortable with my conversions, if I can see those conversions ahead of time, I can get my answer this way. I can do 0.2 times 189,000 gives me 37,800. 37,800. So my answer is $37,800. If you solved this by cross multiplication, you would get the same answer. You would get this same answer of $37,800. Either way, you will get that same answer. Either strategy is good. This strategy in general is a little bit easier to conceptualize because we've been working with ratios already. This strategy over here requires understanding the conversions and the factors at play. More concrete understanding of percentages. But both are valid strategies. How about the next one? About 13% of Germany's population is younger than 15 years old. If there are roughly 10.4 million people, 10,400,000 people, right, in Germany who are younger than 15 years old. So this number and this number correspond to the same value. What is the approximate population of Germany? Once again, it's a ratio 13 out of 100, and that should be equal to, now I know the top value, and I'm looking for the total population, right? The 13% corresponds to the 10.4 million. Now, or if you're comfortable with the percentages, 13% corresponds to 0.13 as a decimal. However, this question is flipped. Notice in this one the x was on top, in this one the x is on bottom. To get my answer here, I would take the 10 million value and divide it by 0.13 to get my answer. Now let's do the cross multiplication and see what we get. We get 13x equals, let's see, multiply that by 100 will give me 10400, 1, 2, 3, 1, 2, put some commas in, will give me 1 billion-ish. Now I got to divide both sides by 13, divide by 13, gives me x equals, let's see, 1040, 1, 2, 3. Oh, I can't fit in my calculator, so we'll have to use a separate strategy. You want to divide 1 billion by 13, 1. It'll give me a nice full calculator of 80 million. So I'll get 80 million when I divide 1 billion by 13. Looks to be about right? 1 billion divided by 10 is 100 million. So if I divide it by 13, it should be a little less than 100 million, right? Divided into smaller groups. Same thing here. Let's see what happens here. If I do 10, 4, 0, 0, 1, 2, 3, divided by 0.13, also gives me 80 million. This also gives me 80 million. So 80 million people. There's 80 million people in Germany according to this example. Now notice, we solved it either way, just like we did this one. However, be careful when you're thinking about percentages. Using the decimal shortcuts requires a more concrete understanding of the picture. Make sure you know whether you need to divide or multiply. When in doubt, always go back to the original ratios. Always go back to the original ratios. If you're ever unsure, you can always backtrack to the original ratios to help you solve these problems. That can be more beneficial. So we saw a few different applications of percentages in this section, and that will help get us started for talking about financial math. That was it for 10.1. Thank you for stopping in, and I'll see you next time.